Okay, so I'm gonna just be working on my code curriculum. I'm doing that curriculum on this book. Figure I would just record some of my process just for posterity. It can be its own video and just sort of outline some of my thinking here. So what is the plan here? The plan is to basically come up with a curriculum that follows this book. This is a very good book on anyone who's going to start to learn to program. And we're just going to go through it a little bit by little bit. I'm going to go through it and I'm going to try and come up with how I want to teach this process. How I want to teach programming. So let's see. Sorry, I'm a little sidetracked here. Okay, so the first chapter is about, he basically goes through an introduction to Morse code, and he talks about powers of 2. So if we think about chapter 1, it's called Two Friends. This chapter is about Morse code and emphasizes powers of 2. Okay, so how would I go about this if I were to start talking about powers of 2? Some of this is also refreshing my own memory about this, so like what do we got? We've got let me see. Powers of 2. Okay. I'm just trying to get my head straight about how I want to think about this. Okay, so if we're representing something in base 2, we're basically using zeros and ones, right? So so the process of binary is basically like that's 0, that's 1, that's 2, that's 3, so we've got 0, 0, 1, 2, 3. That's 4. 0. That's 5. 6. That's 7. Right? The 1 goes over, 1, 2, 3. I've got 1, 0, 0, 0. Got 9. This is how it's done. And 0, 11, 1, 0. Uh, 13. 14. I think that's about right. So okay. Sorry, I haven't done much of this in a while, so I'm just sort of I'm just trying to improve my thinking about it. So let's see. If I made a mistake, sorry. Okay. I want to start with binary because it's kind of the basis of which all computer programming comes from. And my own experience with trying to learn to program has been, one, for me personally, the stuff that's like more low level conceptual, or the low level stuff and the conceptual stuff meet in a very interesting place. Okay, there's this weird thing that happens when you incorporate the math and the concepts, and that it it's a relationship between the fundamentals of dealing with the bare basics of the code, which is all done with binary, and the concepts that you use the code for. And that wasn't the clearest way for me to put it, but we'll try to get there. And I'm just throwing my thoughts out there now. There will be a more polished idea concept to come, but there will be more polished concepts to come. But the primary point here is that we want binary as a basis of understanding what we are doing. A lot of people like to jump right into projects. That's perfectly fine. There are other channels that will walk you through concepts or whatever. But I want to just start right here at the fundamentals. Okay, the bare bones fundamentals. Like I say, we're gonna use this book, and I'm gonna keep building out this curriculum. So okay, so I also want to throw in like other ideas that we can code in binary. Like we've got 0 and 1. I wonder if I can do it like this. Got 0, 1 as a basis. We've got yes, no. We've got, what else can we do? We can do true, false, good, bad, right, okay. So there are some things that we have there that we can code. I probably want to switch these around, huh? Okay, so what else do I want to throw in here? I want to throw in maybe some thoughts around 0. So let's see. Oops. What are my thoughts around 0? Thoughts around 1. Want to talk concept of 0. Okay, so what are some resources on the concept of 0? I've got 0, a history of a dangerous idea. I think that was the name of it. And then thoughts on the concept of 1, thoughts around 1. I don't have any books about the idea of the number 1, but base between 0 and 1. We have this concept of a relationship. Right? Okay, so before you have anything, you have nothing. Does that make sense to have nothing? No, it doesn't make sense to have nothing. You can't have nothing. You can't have nothing. So like you don't literally have nothing. You have a placeholder, right? When we think about having nothing, what we mean is we have absence where we expect something. So this is where like the idea of an expectation becomes important, because 0 only makes sense with respect to some, I guess we would call it, we'll say some expectation. You can think of an expectation as something you would expect to have, right? Likewise, 1 doesn't really make sense without the idea that there can be nothing of that kind. Only makes idea that there can be nothing of that kind. But then think about what the number 1 is doing. The number 1 is implying, as we understand our number system, because we're not building things from the ground up, is the point I'm trying to get at. Most people here are going to have at least basic numeracy. You're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9. You're going to have the Arabic numerals. We have the Arabic numerals. We have these. We understand what they represent. But all of these, every number above 1, every number greater than 1, every number greater than 1 is just a set of ones. It's been a long time since probably a lot of people have done basic arithmetic. Some of you probably have much more advanced mathematics than I do. And part of this whole project is for me to bone up on the mathematics that I want to learn, but I frankly just haven't had the time for. So that's going to be part of this project. So every number greater than 1 is just a set of ones. What do I mean by that? I mean, this is fairly obvious, right? So first you have 1, then you have 2. And what is 2? Well, 2 is 1 plus 1. Well, what does that mean? Well, that's 1 and 1 is another way you could say that. 1 and 1. Well, what does that look like? You could say it looks like it could look like. You could have 2 P's, right? 1, 2. Okay. So what do we see if we're just thinking in terms of P's? So that would be 3, right? 3 P's. We see it's a pattern, right? It's something that's the same, but different. So once we get a greater than 1, we are talking about patterns of stuff in reality. And what is a pattern? Well, I would put forth that patterns don't make sense unless they happen more than once. It can happen as low as twice, but if something only happens once, I would argue that's not a pattern. That would be an instantiation. It would be like it exists, comes into existence. So it's not impossible that you could see if it happens once, it's proof that the thing happening is not impossible, but it's not a pattern. And I would say 2 is the smallest pattern you can have. Having 2 of something is the smallest pattern you can track. Right? So what do we notice when we go back to our 0 and our 1? Our 0 and our 1, well, what is that? That's 2. That's 2. And so you could think about it as 1 and 2. But then, let's take a look at that. 0 and 1 are 2. 2 is a pattern. So it's 1 and 2. But what are we, arithmetically, what are we counting here? We are counting the idea of numbers, right? We're just starting at 0. Which is the idea of nothing. But 0 is actually 1 here. It's the first thing that exists. This is getting a little philosophical, and one way you could just think about it is like you have 0 and 1, and you have 1, 2, where 0 is represented in the first position, and 2 is represented, 1 is represented in the second position, or you could conceptualize this in the reverse order, where 0 represents the first number, and 1 is held at the first place, and 2 is held in the second place, which is the first place, right? So let's think about this some more, right? So we've got 0. So we're doing binary, right? So we've got, let's say we're working out of 4 places. 1, 2, 3, 4. Now we want to represent 1, which is 0, 0, 0, 1, and 2, which is 0, 0, 0, 1, 0. So that's 2. Why is this 2? because we're working out of base 2. Base 2. Base 2. Base 2 only goes up to 2 in any position. So if we were working out a base 10, here's how we would do it. 0, 0, 0, 1. Right? Let's remember base 10. So if we were to do the same thing in base 10, it would be 0, 0, 0, 1. That would be 1. And then 2 would be 0, 0, 0, 2. And then 3 would be 0, 0, 0, 3. And oops. Ugh. Oh my god. There it goes. Hold on. My puppy. Sorry, my puppy's ringing a bell. She doesn't have to use the bathroom, she's just causing problems. Okay. It's been a while since I really lived in Emacs, so I'm just trying to remember the bindings. Okay, so, there. So we've got 4, 5, 6, 7, 8, 9. And 10 would be 0, 0, 1, 0. So that's base 10, right? You've got all these other representations for the other numbers up to 10. And we're used to seeing 10 represented by this, but here 10, as we understand it, the number 10 just means that the place where everything resets gets shifted over 1. Right? We've got a whole set of 10 numbers. So number line wise, you would have like 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And this would be the end of that, right? Here's base 2. And 1. Love you, puppy. Quiet. Oh, I'm getting barked at. What's going on over here? Oh, no, get out of there. Okay. Whoa. So I want us to just notice something. Notice what we're doing. We are translating numbers into other numbers. This idea of base 2 and base 10, we are representing the same thing with something else. This is where math in particular becomes useful, and conceptually where the idea of code, that is encoding, that is translating one thing into another thing, this becomes important. Right? Because we can represent all of these numbers, the base 10 numbers, in base 2. We did that already up here, right? See? There. See, we did it. So it's worth it to just sit with this for a moment and appreciate what's happening with that. Because when we get into more complicated structures, this idea, this translate, the concept here is that we can translate a thing that means something into something else using math. And this is why math is helpful in computer science, right? In programming. Knowing that you have this capability, once you get conceptually how to use it, it will be helpful. How you apply it immediately, that's a little trickier. Like if you want to run into some projects, you certainly can immediately, but this is where we are at right now. And I'm just trying to get my own thoughts down, right? So I'm probably gonna run out of juice soon. Okay, do we want to do Morse code? Then we've got logic and switches. We can talk about states. There are people who hate math, and I don't know how how I'm going to help those people, right? My goodness, puppy. Quiet, quiet, love you, quiet, shut up. Thank you. Oh my goodness, she's so loud. Okay. I think we're good. This is a good start. You know, I just started after work. I'll probably do a lot more later. I'm gonna try to make my setup a little prettier. Because right now it's a little, dude. And this is just like, this is just raw footage, right? Like this isn't meant super for presentation, but my hope is to refine my process a bit as I move along here. I want to do some videos on mindset. That's another important thing. Programming mindset.org. Ways of thinking that help you enjoy the process. It's really like being able to enjoy the process is really important. If you can't enjoy the process, then there's just no getting there. I pushed myself for years to try to enjoy the process, and it wasn't until I had some dalliances with some other ideas, some other concepts, that it became a lot more enjoyable to engage with programming. Okay. I also want to set up some like sessions with people who want some help, and I'm not going to solve their problems for them. I'm just going to help them solve their own problems and come up with a plan for them to get through their own questions, to break through their own problems. I'm pretty sure I can help with that. Okay. I'm just going to stop it here. I'm going to throw this up on YouTube. And it'll be a start, huh? Okay.